Daniel Whitmore was 32 years old when he realized his firewood storage problem had solution literally beneath his feet. Under the cabin floor, where heat from above would keep wood dry and accessible regardless of weather conditions outside. It was August 1858 in the Minnesota Territory near St. Cloud, and the coming winter demanded better storage than the failing lean-to shed that had cost him 2 cords of ruined damp firewood the previous year. Daniel had homesteaded his 160-acre claim in 1856, built a solid log cabin, 16 feet by 20 feet, with raised floor platform elevated 2 feet above ground on stone pier foundations. The elevation was standard practice, kept floor away from ground moisture, provided air circulation preventing rot, created crawl space for accessing foundation repairs. That crawl space was currently wasted volume, just empty air beneath his floor, perhaps 500 cubic feet of unused space sitting idle while he struggled to store firewood adequately outside, where weather could ruin it. The previous winter, 1857 to 58, had taught painful lesson about firewood moisture. He'd stacked 3 cords in a simple lean-to shed against the cabin's north wall. The shed had roof overhang providing vertical rain protection, but no walls to block horizontal weather. Winter storms had driven snow under the overhang. Ground moisture had wicked upward through the bottom layers. The wood had absorbed moisture progressively, becoming damper each week, despite being technically covered. By February, he was burning firewood at 25 to 30% moisture content, damp enough to sizzle and steam when placed in fire, requiring excessive fuel to achieve adequate heat. Had consumed 4 cords, achieving what 3 cords of properly dry wood would have provided. The waste represented perhaps $15 of labor, a week's wages for hired hand, or more importantly, a week of his own labor that could have been spent on productive work. The insight came in late July 1858 while inspecting foundation piers for settling damage. He'd crawled into the space beneath the cabin to examine stonework and noticed the environment was remarkably different from exterior conditions. Outside was hot and humid, typical Minnesota summer with 85 degrees and oppressive moisture in the air. Under the cabin was cooler and notably drier, perhaps 70 degrees with low humidity. The cabin floor above provided complete rain protection. The elevation provided drainage. Any water would flow away rather than pooling. But most interestingly, during winter, the space would benefit from heat leaking downward through the floor. The cabin interior maintained perhaps 55 to 60 degrees, even in coldest weather. Heat would conduct through the floor planks, warming the crawl space to perhaps 45 to 50 degrees, well above freezing, dry conditions perfect for firewood storage. What if he excavated the crawl space deeper, creating actual chamber for firewood storage? The space was already there, already protected overhead by cabin floor, just needed to dig down another 3 or 4 feet, creating 6-foot-tall chamber accessible through trapdoor in the floor. The firewood would stay dry from overhead protection, would benefit from cabin heat, preventing condensation, and would be accessible regardless of exterior weather, no trudging through snowdrifts to frozen outdoor shed. The design crystallized through August. Excavate chamber under cabin floor, 6 feet deep, 12 feet wide, 16 feet long. Install timber walls preventing earth cave-in. Build trapdoor access in cabin floor. Create simple ventilation to prevent moisture accumulation. Stack firewood in the chamber during fall. Access it through winter by opening trapdoor and lowering pieces up through floor. The community's reaction when Daniel explained the plan ranged from skepticism to outright mockery. Firewood belonged outdoors in proper sheds, not buried underground like root vegetables. Digging under an existing structure risked undermining the foundation. The excavated chamber would flood during spring thaw. Wood stored underground would absorb earth moisture, becoming more damp than conventional storage. Marcus Bennett, age 41, a successful farmer and informal leader of the St. Cloud settlement area, tried to talk sense into Daniel in early September when word of the plan spread. "Daniel," he said directly, "firewood storage belongs above ground where it can breathe and season. Your underground chamber will trap moisture. The wood will rot rather than staying dry. You're wasting labor digging under your cabin when you should build proper outdoor shed with walls and ventilation." "Underground stays dry if designed correctly," Daniel countered. "Root cellars keep vegetables dry all winter by staying above water table and providing drainage. Same principle applies to firewood. The cabin floor overhead provides complete rain protection. Heat from cabin prevents condensation. Proper drainage prevents flooding." "What about accessing the wood?" Bennett asked. "Opening trap door to lower firewood up through floor is awkward compared to walking to outdoor shed and carrying arm load back to cabin. Outdoor shed requires me to dress for weather, walk through snow and wind, carry arm load back through weather," Daniel explained. "Underground storage means I lift trapdoor in warm cabin, lower basket on rope, fill it with firewood, raise it back up. Never go outside, never expose myself to weather, never get snow in the woodpile. You're risking foundation stability digging under existing structure," Bennett warned. "Undermining the supports could cause cabin to settle unevenly or worse." Daniel thanked him for concern and proceeded with his plan. The foundation piers were solid stone extending down to stable soil. The excavation would be centered between piers, not undermining their bases. The risk was manageable with careful work. Construction began in early September and required solving the problem of excavating under an existing structure while maintaining its stability. He couldn't simply dig randomly, had to work systematically to avoid undermining support points. The existing crawl space was approximately 2 feet deep from ground level to floor joists. He needed to excavate an additional 4 feet depth, creating total 6 feet of headroom in the finished chamber. The chamber would be 12 feet wide by 16 feet long, roughly 192 square feet of floor area, providing space for approximately 4 cords of stacked firewood. He began excavation at the center of the crawl space, farthest from the foundation piers, would dig in sections, excavate a 4-foot by 4-foot area down to final depth, install timber framing to support the excavated walls, move to adjacent section, and repeat. The technique prevented large, unsupported spans that might collapse during digging. The work was claustrophobic and physically demanding in ways Daniel hadn't fully anticipated when planning the project. He'd crawl under the cabin in early morning, when temperature was coolest, dragging tools and empty buckets with him into the confined darkness. The crawl space entrance was barely 2 feet high, required getting flat on stomach and pulling himself forward with elbows through the opening. Once under the floor, the environment was alien and unsettling. Above him, perhaps 18 inches from his face, were the rough-sawn undersides of floor planks, splinters pointing downward, dust accumulated over 2 years, settling onto everything. The foundation piers rose like stone pillars every 8 feet, creating maze-like space where you couldn't see more than a few feet in any direction, even with lantern light. The excavation technique he developed through trial: lie on back in the area to be excavated, use short-handled spade to loosen earth above his chest, pull loose earth down onto his body, roll onto stomach pushing earth aside, use hands to gather loose earth into bucket position nearby, repeat until bucket full, then drag the bucket toward the exterior opening, crawling and pulling the 30-pound load through confined space, emerge into daylight, dump bucket, return for next load. Each bucket represented perhaps cubic foot of earth removed from the excavation. The total project required roughly 3,000 cubic feet excavated, 3,000 buckets filled, dragged out, emptied. At 20 buckets per 3-hour session, that was 150 sessions. Spread over 5 months, that meant working roughly 6 days per week, accounting for weather and necessary farm work. The physical toll accumulated progressively. His shoulders ached constantly from the overhead digging motion. Lying on back, swinging short spade above chest repeatedly, his hands developed thick calluses from tool handles and from crawling across rough earth, dragging heavy buckets. His back protested from the contorted positions required to work in 18-inch clearance. But the excavation progressed steadily, 4 square feet deeper each session, the chamber growing downward and outward from the center. The dust was relentless and unavoidable. Disturbed earth created clouds of fine particles that filled the confined space, coating everything, including Daniel's lungs. He'd emerge from each session coughing, face and clothes covered in dirt, tasting earth for hours afterward. Would wash in cold creek water, change clothes, cough up brown phlegm, then prepare for the next session. The mental challenge matched the physical burden. Working alone in confined darkness for hours at a time created psychological pressure. The weight of the cabin above felt oppressive. The earth walls seemed ready to collapse. The isolation was profound. He'd talk to himself while working, maintaining mental equilibrium through the sound of his own voice describing the work. Bucket 14 filled, dragging it out now, 20 yards to exit, 6 more buckets today, progress is steady. September and October saw fastest progress. Weather was cool enough that working under the cabin was tolerable. Farm obligations were lighter after harvest. Daniel's body hadn't yet accumulated the cumulative fatigue of months of underground labor. He'd complete 20 to 25 buckets per session, advancing the excavation noticeably each day. November and December slowed the pace. Temperature dropped, but working underground was actually more comfortable than exterior labor. Heat leaking down from the cabin above warmed the crawl space to 45 degrees, even when outside was 0 degrees. The warmth was welcome, but also created humidity. His breath would condense in the confined space, making everything damp. He'd work shorter sessions to avoid the moisture buildup, managing perhaps 15 buckets per day. By December, he'd excavated approximately 3/4 of the planned volume, 144 square feet, excavated to 6-foot depth and timber-framed. The remaining 48 square feet would be completed through January. The timber framing was critical for preventing cave-in and required solving the problem of installing structural supports in confined space while earth walls remained temporarily unsupported during construction. The framing design used grid pattern of vertical posts with horizontal retaining planks. Each post was 6-inch square oak timber, cut 8 feet long, 6 feet to span the excavation depth, plus 2 feet embedded in floor above for anchoring. The posts were positioned every 4 feet in both directions, creating grid of 16 support points distributed across the 12 by 16 chamber. The construction sequence for each 4-foot square cell. Excavate the area to full 6-foot depth, working quickly before earth walls could slump. Install 4 vertical posts at the corners, wedging their bases onto flat stones and their tops against the floor joists above. Nail horizontal retaining planks to the posts, creating timber box that held earth back. The completed cell was stable enough to support its own earth walls, plus provide lateral support to adjacent cells as they were built. The posts were heavy and awkward to maneuver in confined space. Each 8-foot-long 6x6 timber weighed approximately 90 pounds. Daniel would drag them under the cabin one at a time, crawling and pulling the timber through the confined maze, positioning it in the excavated cell, then wrestling it upright while lying on his side in 18-inch clearance. The technique for installing a post: lay it across the excavated hole, with bottom end resting in the hole and top end on the floor above. Crawl into the hole, grab the bottom end, walk the post upright by moving hand over hand up its length while pushing with shoulders and back. When vertical, wedge the base onto flat stone and force the top against the floor joist overhead. The post would be held in place by compression between stone base and joist top, remaining vertical from friction and wedging until horizontal planks were nailed in place, providing permanent stability. Each post took perhaps 30 minutes to install, dragging it under cabin, positioning it, wrestling it vertical, securing it. 16 posts meant 8 hours of pure post installation, not counting the excavation required before each post. The horizontal retaining planks were 2-inch thick oak boards 12 feet long, 6 inches wide. These planks connected the posts, creating continuous wall that held earth back. Each 4-foot span between posts required stacking 8 6-inch wide boards vertically to reach the 4-foot height from excavation bottom to original crawl space level. The plank installation required precise fitting and secure nailing. Daniel would measure and cut each plank to exact length, slide it under the cabin through the confined space, position it against the earth wall between 2 posts, nail it to the posts with large hand-forged nails driven through the plank into the post. The nailing was difficult, working overhead or sideways in cramped position, swinging hammer accurately in darkness, lit only by flickering lantern. The bottom planks went in first, positioned at excavation floor level, connecting posts at their bases. These bottom planks bore the most earth pressure, needed to be seated firmly against stable earth and nailed securely. Next planks stacked above the first, each one overlapping slightly, creating continuous retaining wall rising from bottom to original crawl space level. The cell-by-cell construction meant Daniel was constantly working in partially completed chamber, some areas fully excavated and framed, creating headroom to stand. Other areas still at original crawl space level, requiring crawling, transition zones requiring awkward half-crouch. The work environment evolved daily as the excavation and framing progressed. By mid-December, the grid pattern of timber framing was visually impressive from inside. Looking around the chamber showed regular pattern of vertical posts every 4 feet, connected by horizontal plank walls, creating strong, stable structure, holding back 90 tons of earth above and beside. The cabin floor overhead was supported by both its original floor joists, and now additionally by the vertical posts wedged against those joists from below. The work slowed during December cold, but continued whenever temperature allowed. The confined space was actually warmer than exterior air. Heat leaking downward through cabin floor warmed the crawl space to 45 degrees, even when outside was 0 degrees. He could work comfortably in the excavation when outdoor labor would have been miserable. By mid-January 1859, the excavation was complete. 6 feet deep, 12 feet wide, 16 feet long, fully timber-framed to prevent collapse. The floor was earth-packed smooth, with slight slope toward drainage trench leading to exterior. The ceiling was the underside of his cabin floor, rough-sawn planks supported by floor joists, now serving as roof for his underground chamber. The trapdoor was cut through cabin floor near the center, positioned between floor joists for structural integrity. The opening was 3 feet square, adequate for passing firewood bundles, but not so large that it weakened floor significantly. He built simple trapdoor from planks, hinged on one side, with rope handle for lifting. The ventilation was passive but effective. Small gaps existed naturally between cabin floor planks. Thermal expansion and wood shrinkage created 1/8-inch gaps every few feet. These gaps allowed cabin air to circulate downward into the chamber, carrying warmth and preventing moisture accumulation. He didn't need to install special ventilation. The natural gaps provided adequate air exchange. He tested the system in late January by stacking 2 cords of firewood in the chamber, wood he'd cut and split during summer and fall, initially stored outside, but now moved underground. Would monitor moisture content through remaining winter to verify the chamber kept wood dry. The chamber environment proved ideal for firewood storage. Temperature maintained 45 to 50 degrees throughout February and March, well above freezing, warm enough to prevent condensation. The overhead protection from cabin floor kept wood completely dry from precipitation. The passive ventilation from floor gaps provided gentle air circulation, preventing stagnant humidity. He checked the wood weekly through February and March, examining pieces from different locations in the stack. Would split sample pieces to inspect interior moisture. Every piece remained at 15 to 18% moisture content, properly seasoned, ready for efficient burning. No increase in moisture despite being stored underground. The convenience factor exceeded his expectations. During blizzards, when outdoor access was dangerous, he'd simply lift the trapdoor in warm cabin, lower woven basket on rope, fill it with split pieces, raise the basket back up. Total exposure to cold, 0 seconds. Total walking through snow and wind, 0 feet. The firewood came directly from protected storage into his warm cabin without him ever going outside. The contrast with conventional outdoor storage became apparent during the brutal March 1859 blizzard. 4 days of sustained snow and wind that made outdoor travel dangerous and conventional firewood access difficult or impossible. Marcus Bennett's household had firewood stacked in proper outdoor shed with walls and roof. The shed was well built, expensive construction using milled lumber. But accessing it required dressing for weather, walking 30 feet through wind-driven snow, opening shed door against wind pressure, selecting and loading firewood, carrying it back through blizzard, tracking snow and ice into cabin. During the 4-day blizzard, Bennett made 4 trips daily to his shed, 16 total expeditions into dangerous weather. Each trip meant perhaps 3 minutes exposure to minus 10 degrees with 40-mile-per-hour wind chill, approaching minus 40 degrees. The cumulative cold exposure was dangerous, especially for children sent to fetch firewood when adults were occupied. His firewood arrived wet from blown snow that infiltrated the shed despite walls and door. The snow would melt from cabin heat, dampening the wood surface. The damp wood would burn poorly until dried by fire heat, wasting fuel and creating excessive smoke. Daniel's underground chamber performed effortlessly. When he needed firewood, he'd lift trapdoor, lower basket, fill it, raise it. Total time, perhaps 90 seconds. Total cold exposure, 0. He never left the warm cabin. The firewood emerged perfectly dry, ready to burn immediately at maximum efficiency. Bennett visited on March 22nd, after the blizzard cleared, ostensibly checking on neighbors but actually consumed by need to understand how Daniel had survived 4 days of brutal weather without visible outdoor woodshed access or signs of fuel shortage. He arrived mid-morning to find Daniel's cabin warm and welcoming, smoke rising steadily from chimney, indicating active fire, windows showing interior lamplight, suggesting adequate fuel for heating and lighting. But no outdoor woodshed was visible anywhere, no tramped-down path through snow from cabin to storage structure, no stacked firewood against exterior walls. The firewood supply seemed to exist without existing anywhere. "Where's your firewood?" Bennett asked directly when Daniel opened the door. "Watched your cabin during the 4-day blizzard. Never saw you make trips to outdoor shed. Counted chimney smoke. You were burning steady all 4 days. Your fuel supply had to be somewhere, but I couldn't see outdoor storage structure anywhere. Figured you'd built something on far side of cabin I couldn't observe from my place." Daniel smiled with quiet satisfaction. The smile of someone who'd solved a problem everyone else thought unsolvable. "Come inside," he said, stepping aside to let Bennett enter. "I'll show you something nobody expected would work." Bennett entered the warm cabin, stomping snow from boots, looking around for clues to the firewood mystery. The cabin interior was standard layout, fireplace on north wall with healthy fire burning, simple furniture arranged efficiently, cooking area near fireplace, sleeping area on opposite end. No firewood stacked inside taking up valuable living space, no visible door or passage leading to attached storage structure. Then Daniel walked to center of the cabin floor and knelt down beside what Bennett had assumed was normal floorboard joint. Ran his fingers along the board edges, found the rope handle, lifted. A 3-foot square section of floor hinged upward, revealing trapdoor opening into darkness below. Bennett stood frozen, processing the impossible. There was chamber beneath the cabin floor, deep enough that lantern light didn't immediately reveal the bottom. Large enough that the opening was 3 feet square, but the space below extended beyond in all directions, and based on the visible stacked firewood in the lamplight, the chamber contained significant wood supply. "Underground," Daniel said simply, gesturing to the opening. "Excavated chamber, 6 feet deep, 12 feet wide, 16 feet long. Stores 4 cords completely protected from weather. Access is through this trapdoor. I lower basket on rope, fill it, raise it back up. Never go outside, never expose myself to cold. Firewood comes directly from protected storage into warm cabin." Bennett walked to the opening and looked down into the chamber. A ladder descended into darkness. Stacked firewood was visible in the lamplight, neatly arranged cords extending into shadows. The chamber appeared dry despite being underground. No standing water, no visible dampness on the wood surfaces. "May I?" Bennett asked, gesturing to the ladder. "Please," Daniel confirmed, lighting additional lantern to provide better visibility below. Bennett descended carefully, boots finding ladder rungs, lowering himself into the underground chamber. Stood on packed earth floor, straightening to full height with his head clearing the floor joists above by perhaps 6 inches. The chamber extended in all directions beyond the trap door opening, 12 feet wide, 16 feet long, impressive volume of space hidden beneath the cabin. The environment was immediately noticeable for being warmer than expected. Outside temperature was perhaps 20 degrees with wind. The underground chamber was noticeably warmer, perhaps 48 degrees, comfortable enough that Bennett unbuttoned his heavy coat within moments. The air felt dry, not damp like cellars often were. The firewood stacked against walls looked perfectly dry, clean splits without surface moisture or frost. Bennett placed palm against the underside of the cabin floor overhead. The planks were warm to touch, perhaps 55 degrees. Heat from the cabin's interior fire was conducting downward through the flooring, warming this underground space significantly above exterior temperature. That warmth prevented condensation that would have dampened stored wood. He examined the timber framing holding back earth walls. The vertical posts and horizontal retaining planks created solid structure, showing no signs of stress or failure. The construction was careful and competent, not the reckless undermining of foundation that everyone had predicted would cause disaster. "You excavated 90 tons of earth beneath your existing cabin," Bennett said slowly, the full scope of the project becoming clear. "Did it without undermining the foundation. Built timber framing to prevent collapse. Created chamber that stays warm from heat leaking through floor above. And stored firewood in conditions that keep it drier than my expensive outdoor shed keeps mine." "The space was already here," Daniel explained from above. "Every cabin with elevated floor has crawl space beneath it, usually wasted volume, serving no purpose except foundation access. I just made that space deeper and put it to productive use. The cabin floor provides perfect overhead protection from precipitation. The foundation elevation provides drainage. Heat from cabin prevents condensation, all the advantages of covered storage with added benefits of warmth and interior accessibility." Bennett selected piece of firewood from stack, examined it closely. The wood was completely dry, 15% moisture content based on how it felt and sounded when struck against another piece. Compare that to his own firewood at 25% moisture after sitting in outdoor shed through wet winter. The underground storage was objectively superior, despite seeming counterintuitive. "During that 4-day blizzard," Bennett calculated, "I made 16 trips to my outdoor shed. Each trip meant 3 minutes exposure to -10 degrees with 40-mile wind. 48 minutes cumulative exposure to life-threatening cold. My firewood arrived wet from blown snow that infiltrated the shed. Your system required you to open trap door in warm cabin and lift firewood up through floor. 0 cold exposure, 0 weather exposure. Wood arrived perfectly dry, ready for immediate burning." "Convenience was unexpected benefit," Daniel admitted. designed this primarily for keeping wood dry through protection and warmth. The all-weather accessibility turned out to be equally valuable. Can load fireplace at any hour in any weather without ever leaving the cabin. That's worth significant comfort and safety, especially for family with children who might otherwise be sent outside for firewood during storms. Bennett climbed back up the ladder into the cabin, sitting on the floor edge with legs dangling into the chamber, while he processed the economics and logistics. "Material costs?" he asked. $8 for oak timber, posts and retaining planks, Daniel itemized. $2 for trapdoor hardware and hinges, $10 total materials. Labor was 5 months at 3 hours daily, roughly 450 hours total, but that labor was distributed over months when other farm work was limited anyway. The space itself was free, already existed, just needed excavating and framing. "My outdoor shed cost $35 materials and 80 hours labor concentrated in 2 weeks, Bennett compared. "Your underground chamber cost $10 and 450 hours distributed labor. Yet your firewood stays drier, is more conveniently accessed, and doesn't require me to build or maintain separate exterior structure. The underground approach is superior in almost every metric except total labor hours, and those hours were spread out enough they didn't interfere with other obligations." By spring 1859, 7 households in the St. Cloud area had excavated underfloor firewood chambers following Daniel's design principles. The construction was labor-intensive but used space that already existed under elevated cabin floors. The performance exceeded outdoor storage while costing less. Daniel became informal consultant, helped neighbors plan excavation sequences to avoid undermining foundations, advised on timber framing dimensions and techniques, designed drainage systems for different soil conditions, was paid in labor barter, sometimes tools or materials, occasionally small amounts of cash. The recognition and income exceeded anything he'd gained from conventional farming alone. He lived in the cabin with underfloor storage until 1873, when he sold the homestead and moved to St. Cloud proper to work as building contractor. The underfloor chamber remained functional for 15 years of continuous use, demonstrating the design's durability and effectiveness. Daniel lived until 1906, dying at age 80. His obituary mentioned his homesteading and his contracting business, but focused primarily on the underfloor firewood storage, the hidden chamber that proved the best storage isn't always the most visible. Modern analysis of the few surviving underfloor chambers confirmed the effectiveness. Conventional outdoor storage, maintaining wood at 20 to 30% moisture content, underfloor chamber maintaining wood at 15 to 18% moisture content, representing 20 to 30% improvement in fuel efficiency while providing all-weather accessibility. The story is about a man who understood that the best solution sometimes means using space you already have, rather than building new structures, who recognized that protection from above combined with heat from above created ideal storage conditions, who proved that hiding your shed under your cabin wasn't hiding from the problem, it was solving the problem better than anyone expected. Because sometimes staying dry isn't about building bigger roofs, it's about putting storage where roofs already exist. The chamber everyone called dangerous was actually superior engineering, and $10 spent using existing space worked better than $35 building new structure.